Hello everybody, it's Mr. Ray here with our next lesson in grade 11 University Math. We have started the unit called trigonometric functions, and in the previous lesson we looked at periodic functions to understand what they are and the types of measurements we used. We had two measurements for periodic functions: the period, which is the horizontal distance before the graph or the function repeats itself, and the amplitude, which is half the distance between the min and the max. So today we're actually going to we're going to look at our first periodic functions, which will be the stars of this unit, and that they are the sine and cosine functions. So I'm going to take a little trip back to the previous unit when we looked at the trig ratios as we go around the unit circle. So what I've done here, maybe I'll zoom out a little bit. So I've made a table of values. Okay, now you can see we've got the angle here, and you can see the exact angles we used on the unit circle: 0, 30, 45, 60, basically all the multiples of 30 and 45 until we get right back to, well, we don't get quite back to 360, but 360 would be the exact same as 0. So if you look to the left here, we have another measurement for theta in different units than degrees. These are called radians, and you don't have to, we won't be talking about them at any other point than what we are right now. These are the units that we'll be using in grade 12 advanced functions. It's just another way of measuring an angle. Okay, so I will fold that back so you don't have to worry about what that means. Okay, and if I look at my table now, okay, so I've now got my degrees down the left column, so that's my input variable. And then I've actually defined my functions here. Now, again, we're only going to be talking today about sine theta and cos theta. So these will be our sine function and cosine function. I've also put the measurements for the other 4 trig ratios, but again, we're not going to use those. They're not nearly as useful as sine and cosine are. So again, I'm going to fold those off so that we just look at our favorite 2 functions, sine and cosine. So, okay, so where do these come from? Well, I don't have my unit circle in front of me, but if you went around the unit circle and you look for your sine values, remember the sine values, this is your y coordinate as you go around the unit circle. So it started at 0 degrees, it was 0, and then 1/2, and 1 over root 2, or root 2 over 2, same thing, root 3 over 2, then all the way up to the top, the sine ratio was 1, and then it starts going back down again. You can see the pattern of numbers here are those coordinate values from our special triangles that we used: 1/2, 1 over root 2, and root 3 over 2. And once we get past 180, you can see, well, the sine value starts having some negative versions of those values. Now, same thing happens with cosine. When we start at 0 degrees, we look at the x-coordinate of that point, and it's this time it's 1. So you can see they're not the same. They're actually only the same at a couple of points, and that's like the 45-degree values. But this is starting at 1. If I go to 30 degrees, remember the unit circle had root 3 over 2 and this is the x-coordinate. Okay, and you can see it kind of, it starts at 1, works its way down to 0. Between 90 and 180, it starts getting more and more negative till it gets down to -1, and then it starts going up again. As we get to 270, it gets back to 0, and at 360, you get back to 1. Okay, so you can see sort of a little pattern going on with both of these functions. So we're actually going to turn this table of values into functions. So I'm just going to use this as my input. Sorry, the angle is the input of the functions, and the sine and the cosine of those angles will be our y values. So if we, well, one other thing I want to say, so when you're graphing some of these, it's like who knows what root 3 over 2 is, and you'll start to recognize these values quite a bit once you start using calculations. 1 over root 2 as a decimal is 0.707, and root 3 over 2 is 0.866. So you can see the value, 1/2 is 0.5. So it goes 0.5, 0.7, 0.866, 1. And then it starts going back down again. 0.866, 0.707, 0.5, back to 0. Okay, and then you get the negative values. But it's kind of good to know what these values actually are in decimal, because when we actually plot these values on our chart, you'll actually need to know where they are. So once we do that, so if I take the table of value for sine, let me zoom in a bit more. So if I'm applying this sine function, you can see, okay, so at basically the x coordinate of 0, sine theta is 0. So that's the point right there at 30 degrees. And you can see, I didn't really talk about the axes here. The axes of this function, the x-axis here is the angle in degrees. You can see 90, 180, 270, 360. So that's the angle along there. That's our input variable, and our output variable will be the result of the sine value, the sine ratio for that angle. And you can see if you looked at the values here, well, they start at 0, go up to 1, back to 0, and then to -1. So it basically kind of oscillates between 1 and -1. So we only had to draw that portion of the vertical scale. Okay, so if we keep going with our plotting, you can see, okay, if x is 30, the y value is 1/2, so that would be that point right there. If x is 45, we're at 0.707, so it's the point there, which, I mean, you're approximating here, but that's the point there. And then at 60 degrees, it's 0.866, which is about there. And at 90 degrees, it's up to 1. And you can continue plotting these points, and you'll actually make this graph. Okay. Now we could make this a little bigger in terms of maybe go outside these values. We could use a calculator and find, say, the 70 degrees or 20 degrees, but you'll see those points also lie right on this curve. So once we get enough points, which I think this is enough, we can then just kind of sketch our curve. You can see it's a nice smooth flowing curve. It's not like it's not pointy or jagged or anything. It's very nicely smooth. Okay, so when you're drawing your curves, please try to make sure that it's nicely curved. It's not like a jigsaw puzzle where you just jagged little edges of straight lines. Okay, so that is the graph of y equals sine x. Okay, and you can see it kind of ends where it began. Now, if we kept going around the circle a second time, if we got up to, say, 390 degrees, well, 390 degrees is the same as 30. You know, those are coterminal angles. So as we go around the circle a second time, we would just repeat these same values over again. So this is one complete cycle of sine x because it does repeat itself. You could also go with negative angles for theta and see that, well, this graph would continue nicely flowing from where it left off on the left end. So it does continue infinitely in both directions if you were to plot some more angles to get your points. Okay, and we could do a similar plotting for cos x. Let's move this right over this time. It's hard to see this one. How about, yeah, let's do it this way. Okay. All right, so for cos x, remember at 0 degrees it was 1, so the graph starts right up at the top. Okay, and then it works its way down. So remember that's 0.866, 0.707, 0.5, continues down. You get down to 0 at, that would be 90 degrees. And then you go more and more negative. So this would be 120 is negative a half, 0.707, negative 0.866, and so on. It just continues around. Get all the way down to negative 1 at your negative, sorry, looking at the wrong one here. You get down to negative 1 at 180. So you're down to this is the minimum of the function. And then you start climbing back up again. So you repeat these same points again, and then you get back to 360 and you're all the way back to 1. So you can see a lot of similarity in these two graphs. And we can actually make one from the other, and we'll talk about that later. But let's look at the characteristics of these two functions now that we've actually created them, or at least saw how we can create them. If we compare the minimum values, they both have a minimum value of this should be reversed. So this would be maximum value, and this would be minimum. Never noticed that before. So maximum values of 1, and you can see that sine x has 1 of those, and cos x has 2 of them. Minimum values of negative 1. And in terms of domain, okay, like I said before, these two functions can continue infinitely in either direction. You could have, extremely big negative angles, extremely big positive angles. So in terms of domain, x can be any real number. Okay. Now the range is more restrictive, like we talked about the min and the max of 1 and negative 1. So the y values have to be between 1 and negative 1. So that says the range is restricted, that y is greater than or equal to negative 1, less than or equal to 1. If we looked at some of the key points, the x-intercepts, so where does the curve intercept the x-axis? Well, it happens at 3 places for the sine x function, at 0 degrees, 180 degrees, and 360. Whereas there's only 2 of them for cos x function, that they happen at 90 degrees and 270. Okay, and then also in terms of the other intercept, the y-intercept, so the y-intercept of sine x is 0, and the y-intercept of cos x is 1. Okay, so it's a very short lesson today, just discovering these two new functions, some of their characteristics, how we built them, and they're going to be front and center for the rest of this unit. We're going to be talking a lot about them. Now, you might have been curious, well, why are we just doing, the cos function and the sine function? We've got, we have a choice of 4 others to do here. If you actually graph these, one thing you notice about these values here, you see a lot of undefined values, and that always means that you've divided something by 0. And that happens quite a bit with these reciprocal functions because, sine x and cos x a lot of times had a 0 on the top. So when you flip it upside down, the 0 goes on the bottom. Now, if you were to graph any of these, they're fairly ugly looking functions. They are periodic, but they've got lots of what we call vertical asymptotes. Basically, these functions can go way up to positive infinity, down to negative infinity. And in terms of actually using them for applications, I've yet to see a good application question around any of these functions. So there's lots and lots of good ones for sine and cos. So we are sticking just to our friends, our functions sine x and cos x, or whatever variable you'd like to use for the angle. Okay, so we'll be getting more in depth into those two functions on the next lesson, and then seeing some applications of these functions and how we can transform them. Okay, so that's it for today. I do have two little questions for you to just practice a little bit before we get into the next lesson. So, hope that made sense, and we'll see you on the next lesson. Take care.